Leaf springs. Although leaf springs were the first type of suspension spring used on automobiles, today they are generally found only on light-duty trucks, vans, and some passenger cars. There are three basic types of leaf springs: multiple leaf, monoleaf, and fiber composite. Multiple leaf springs. Multiple leaf springs consist of a series of flat steel leaves that are bundled together and held with clips, or by a bolt placed slightly ahead of the center of the bundle. One leaf, called the main leaf, runs the entire length of the spring. The next leaf is a little shorter and attaches to the main leaf, and so on. This system allows almost any number of leaves to be used to support the vehicle's weight. It also gives a progressively stiffer spring. The spring easily flexes over small distances for minor bumps. The farther the spring is deflected, the stiffer it gets. The more leaves, and the thicker and shorter the leaves, the stronger the spring. It must be remembered that as the spring flexes, the ends of the leaves slides over one another. This sliding could be a source of noise, and can also produce friction. These problems are reduced by interleaves of zinc and plastic placed between the spring's leaves. As the multiple springs slide, friction produced a harsh ride as the spring flexes. This friction also dampens the spring motion. Multiple leaf springs have a curve in them. This curve, if doubled, forms an ellipse. Thus, leaf springs are sometimes called semi-elliptical or quarter-elliptical. The semi or quarter refers to how much of the ellipse the spring actually described. The vast majority of leaf springs are semi-elliptical. Leaf springs are commonly mounted at right angles to the axle. In addition to absorbing blows from road forces, they also serve as suspension locators by fixing the position of the suspension with respect to the front and rear of the vehicle. A centering pin is frequently used to ensure that the axle is correctly located. If a spring is broken or misplaced, the axle might be mislocated and the alignment impaired. The front eye of the main leaf, at either end of the axle, is attached to a bracket on the frame of the vehicle with a bolt and bushing connection. The rear eye of the main leaf is secured to the frame with a shackle, which permits some fore and aft movement in response to physical forces of acceleration, deceleration, and braking. Monoleaf springs. Monoleaf or single-leaf springs are usually the tapered plate type with a heavy or thick center section tapering off at both ends. This provides a variable spring rate for a smooth ride and good load-carrying ability. In addition, single-leaf springs do not have the noise and static friction characteristic of multiple-leaf springs. Fiber composite springs. While most leaf springs are still made of steel, recent years have shown the fiber composite types increasing in popularity. Some automotive people call them plastic springs, in spite of the fact that the springs contain no plastic at all. They are made of fibreglass, laminated, and bonded together by tough polyester resins. The long strands of fibreglass are saturated with resin and bundled together by wrapping, a process called filament winding, or squeezed together under pressure, using compression molding technique. Fiber composite leaf springs are incredibly lightweight and possess some unique ride control characteristics. Conventional monoleaf steel springs are real heavy weights, tipping the scale at anywhere from 11 to 20 kilograms apiece. Some multiple leaf springs can weigh almost twice as much. A fiber composite leaf spring is a featherweight by comparison, weighing a mere 3.6 to 4.5 kilograms. As every performance enthusiast knows, springs are dead weight. Reducing the weight of the suspension not only reduces the overall weight of the vehicle, but also reduces the sprung mass of the suspension itself. This reduces the spring effort and amount of shock control that is required to keep the wheels in contact with the road. The result is a smoother riding, better handling, and faster responding suspension, which is exactly the sort of thing every performance enthusiast wants. Other advantages of using fiber composite springs includes the following. A quieter ride. A fiber composite spring does not resonate or transmit sound like a steel spring. In fact, it actually dampens noise. A smoother ride. Because fiber composite springs use a one-piece monoleaf design, there is no rubbing friction like there is between the leaves in a multiple-leaf steel spring. No spring sag. All steel springs sag with age, whether leaves or coils. Spring sag affects ride height, which in turn alters wheel alignment, handling, steering, and braking. A weak spring can load the suspension unevenly, allowing the wheel under the weak spring to lose traction when accelerating or braking. According to the manufacturers of fiber composite springs, there is no sag with age. Less body roll. In applications where the leaf springs are mounted sideways or transversely, the spring also acts like a sway bar to limit body sway and roll when cornering. This load transfer characteristic also permits softer than normal spring rates to be used for a smoother ride. With fiber composite leaf springs, there is little or no danger of the spring suddenly snapping. The laminated layers create a built-in fail-safe mechanism for keeping the spring intact should a problem arise. Air springs. Another type of spring, an air spring, is used in an air-operated microprocessor control system that replaces the conventional coil springs with air springs to provide a comfortable ride and automatic front and rear load leveling. The air springs are located in the same positions where coil springs are usually found. Each spring consists of a reinforced rubber bag pressurized with air. The bottom of each air bag is attached to an inverted piston-like mount that reduces the interior volume of the air bag during journeys. This has the effect of increasing air pressure inside the spring as it is compressed, making it progressively stiffer. A vehicle equipped with an electronic air suspension system is able to provide a comfortable street ride, about a third softer than conventional coil springs. At the same time, its variable spring rate helps absorb bumps and protect against bottoming.